Okay, I'm going to show you how to do this weighing a means of counting lab. The first thing that you're going to want to do is to copy down the data table on the board. And then after you get that copied down, you and your lab group, your partners at your table, can go around in the back and you're going to measure the mass of the following objects: glass, aluminum, lead, sodium chloride, sugar, and water. Make sure you record all the digits on the balances and zero the balances before starting. Make sure the balances are in grams. All right, now what I'm going to do is I'm going to show you copper and baking soda. I'm going to do two examples. You don't have to do those two. I'm doing those two examples. Just do the ones in the back. So you're going to measure the masses of 6 things in the back. All right, then I'm going to show you copper and baking soda, how to do the problems. Okay, now what I want you to do is I want you to copy this down, and actually I'll have the sample problems on the board, but copy these two examples into your notes or into this lab. You're not going to turn it in, it's just for practice. But I want you to watch how I do this problem. All right, so what we're trying to do on all these problems is we're trying to figure out how many atoms there are in whatever we weigh in the back. So what we want to do is we want to know 12 grams of copper equals how many atoms. So for this whole lab, you're solving everything for atoms. Okay, to do that, the first thing that you do is you write down what the problem gives you. So 12.000 grams copper. You draw the picket fence. All right, now the only thing that you can change grams to is moles. If you look at the mole map or you look at the conversions on the board, the only thing you can do is change it to moles. And so in 1 mole of copper, if you look at the periodic table, the red number, you can see that 1 mole of copper is equal to 63.5 grams. Now I just go to the nearest tenth. All right, round to the nearest tenth. Okay, now grams will cancel. Now we need to change moles to atoms. And so you're going to look and you're going to say, well, okay, 1 mole of copper, you're going to follow the principle of diagonality, so the units diagonal will cancel. And then you're going to go 6.02 e to the 23rd. But when you write this 6.02 e to the 23rd, your label could be atoms, molecules, or formula units. Okay? So let's review here. If you had something like copper, see, it's by itself. It's not with anything. So you can call copper an atom. But if you had something like copper 2 fluoride, which would be CuF2, okay, this is an ionic compound. Ionic compounds make formula units. Okay, and if you had something like, let's just say, methane gas, CH4, if the first element is a nonmetal, that makes it a molecule. All right, so when you're using this step right here, 1 mole of something equals 6.02 e to the 23rd, you have to choose atom, a formula unit, or a molecule. If it's something by itself, you can call it an atom. Okay, so that's how many atoms of copper. If the first element starts with a metal and then it's with something, it's a formula unit. And if the first element is a non-metal, you can be safe in calling it a molecule. Now, I know that I need to stop this problem because my answer, the unit at the top right hand, matches what I'm looking for. And so I'm going to push the buttons on the calculator and see what this is. So 12 times 6.02 e to the 23rd divided by 63.5. And your calculator is going to say something like 1.1376377. So it's this big long number, and there's probably more digits than that. E to the 23rd power. All right, but in this lab also, we're going to work on significant digits. Your answer has to match how many significant digits are in the original measurement. And so in this problem, there were 1, 2. Now, zeros are counted trailing zeros are counted when there's a decimal point in the number. So we got to count these zeros. So this has 5 significant digits. So we need to round our answer to show 5 significant digits. So there's 1, 2, 3, 4. Before we write the 6, we make sure it doesn't round up, which it doesn't. 5. So that matches how many that I started with. E to the 23rd, put a label on it. Atoms, copper. This would be the correct answer. Okay, now I want you to compare this one, and I'll have these calculations on the board, but you can look and compare this one, the copper one, to the next one, which will be baking soda. All right, so here's the baking soda one. It's a little bit different. Okay, so just like before, what we're going to do is we're going to start off and we're going to write down what the problem gives us. 5.03 grams of baking soda. We draw the picket fence. Okay, the only thing you can change grams to is moles. And remember, all these problems we're trying to get atoms. We're trying to solve for atoms. So the first thing is we're going to change the grams here to moles using the molar mass. Okay, but you can't look on the periodic table and just find NaHCO3. You have to add it up. So you got to figure out how many of each are in the formula. So 1 sodium, and if you look at the periodic table and you round sodium to the nearest tenth, it's about 23.0 grams. So 1 times 23 is 23 grams. There's 1 hydrogen in baking soda, and it's about 1 gram if you round it. So 1 times 1 is 1. There's 1 carbon, and each carbon, if you go to the nearest tenth, is about 12 grams. So that's going to equal 12.0 grams. And there are 3 oxygens, and each oxygen is about 16 grams. And so if you multiply 3 times 16, that gives you 48 grams. Now you just have to add all this up, and this is how you get a molar mass for a compound. And if you add it all up, it equals around 84 grams. So that's the molar mass of baking soda. So I'm going to write that right there. That's how many grams. That's the molar mass. Now I've just changed to moles, but I don't want moles, I want atoms. So I got to do another step. Okay? Now the next step would be going to some type of particle. So I'm going to go 1 mole baking soda. Notice how I kept my units diagonal. All right. Now baking soda, the first element in the formula is a metal. So that makes baking soda not an atom, it's a collection of atoms. It makes it a formula unit. So anyway, that we have 6.02 e to the 23rd. We're going to use that, but we can't call it atoms right away. We have to call it a formula unit. All right. So formula units of baking soda. Okay, now we got to do one more step because we don't want formula units, we want atoms. If the problem wanted formula units, we would stop because if these units cancel, we would be in formula units if we did the math. But we want atoms, so we're going to do one more step. And the one step that we're going to do is, you can see on the board there's a conversion factor that says in 1 formula unit there's blank atoms. Well, we're going to count the atoms. There's 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. So that means that there are 6 atoms in 1 formula unit. So we're going to write 6 atoms up here. Then we're going to do the math. And if you do the math on that one, it equals, I'm going to write it down here, I'm out of room, 2.1629 e to the 23rd. But we have to worry about significant digits. So we've got 1, okay, sandwich zeros are always counted, 2, 3 significant digits. So we got to round to 3. So my answer would be 2.16 e to the 23rd atoms. That would be the correct answer. So the steps for today's lab are to watch this video, which you've already done if you're this far. Number 2, make sure you copy down the data table on the board and put the sample problems for the copper and the baking soda into your notes so you have something to refer to. The rest of the problems will be done pretty much the same. You just have to uh, uh, figure out if it's going to be a 3-step problem or a 2-step problem. All right, good luck.